Okay, so the first thing I'm going to say, if anybody's watching the clock carefully, originally I had 20 minutes and Michael K had 40 minutes, and I was supposed to cover XQuery and XPath 3.0, the current generation, plus the next generation, 3.1. So he agreed that I could steal a little bit of his time, so don't get too anxious when I start doing that. I'm going to be talking about two different things. I'm going to be talking about the 3.0 specifications. Those are currently proposed recommendations. They're almost finished. If somebody finds problems in them, that can be changed. But we're not looking at new requirements. We're making small changes if anything needs to be fixed, and we're hoping very much that nothing does need to be fixed. We'd like to just go to recommendation status. And we also have the 3.1 specs. You'd think that if it differs by 0.1, that it's not a big difference, but the 3.1 specs are starting a whole new set of work, primarily on things related to maps, arrays, JSON, and the ability to integrate different kinds of data. In today's talk, I'm actually going to focus on only 4 parts of XQuery 3.0 and XPath 3.0. I'm going to focus on the parts that are maybe a little bit harder to understand and that have more of an impact. I'd like to be able to tell you which of these are the most important parts, but that really depends very much on who you ask. In general, database kinds of people will tell you that grouping and windowing may be the most important parts. Functional programmers will tell you that all the things we've done with functions and higher order functions are the most important parts. And people who are doing various kinds of integration in web applications where you can't afford to have errors just crash things will tell you that error handling is one of the most important parts. So I thought those were all good candidates to discuss. I'm not going to be talking about a lot of things that make it easier to structure your code, make queries read more nicely, things like that. Switch expressions, count clauses in flower expressions, very useful. Private functions. Computed namespace constructors actually allow you to create namespaces dynamically. And that allows you to do things like read a schema and create things based on what you're learning about the namespaces in the schema. Output declarations are used for serialization. String concatenation operator is just syntactic shorthand for string concatenation. You do a lot of that. Simple mapping operator allows you to avoid writing a lot of flower expressions with a single character. Function annotations, variable annotations. If you know what those are in another language, you have some idea what they are in XQuery. I'm not talking about any of these things because I think you can read these things in the specification pretty quickly. And I don't think that these are the most important things given the small amount of time I have to cover a lot of things. On to 3.1, which is, again, the next generation of our specifications. The main things that we're adding here are maps and arrays. If you know another programming language, you may know maps as dictionaries or hash tables or as associative arrays. Arrays you probably know under that name. We're doing this primarily for 2 reasons. For our internal programming, to be able to pass parameters around more easily, to be able to create intermediate structures that are lightweight to represent things like groups that are created independently of the final markup that you might use, to make some things more optimizable. And we're doing it because there's a lot of JSON out there, a lot of JavaScript objects, because we need more lightweight ways to integrate with that kind of data. I'm the first person here who works with XML primarily, speaking at this conference. And I think that on the back end, we do run into a lot of XML together with other kinds of data. It may not make its way to the browser, but document data doesn't go away. Structured documents don't go away. And we have a combination of XML kinds of documents, HTML kinds of documents, JSON data. All of that needs to be combined. And that's one of the big things that we're looking at in XQuery and XPath 3.1. We're also doing a couple of things like support for scientific notation. I won't be talking about that at all. invoking XSLT transforms from queries. That's only a may requirement, but I hope very much that that gets done. There's been some good work done on that. Standard names for collations, again, only a may requirement, but it would really go a long ways towards interoperability. In this talk, I'm going to be focusing on maps and arrays. So what happened in XQuery 3.0? The first thing is we got grouping. Grouping allows you to do a variety of queries where you care about, say, businesses on a particular street in a given zip code, or products sold by a particular store, where you're creating groups based on the data that's there. What grouping does is it partitions your data based on grouping keys. So you'll take a set of values. Any item that has a shared set of values belongs in the same group. It's often used together with sum, count, and average. So you want to know for each group, let's say that you have a region, what are its average sales? What are its total sales? How many things were sold? How many stores are there? Things like that. It's often used together with XML constructors to create XML hierarchies. So you'll create an element to represent a region, and then you'll create some kind of results within that region. This next bullet point I don't expect anybody to understand. I say that it transforms the input tuples. One tuple is created for each partition. Each variable contains a sequence of all input values that contributed to the partition. If anybody understood what I just said, they're probably on a working group. But I'm going to show you some sample queries that I hope will clarify that. Okay, I may have to shift my screen around a little bit. Now, okay, so here I have a bunch of products. And you can see that I have a name and a category and a price and a cost. And I have a bunch of those. And here I have a query. And in my query, I'm going to group by the product name. I'm going to sort by the product name. And then I'm going to create a product element that has a name and the amount of sales per product. I'm sorry this looked better on my screen when I originally did this. Okay, so something that you may want to know is, well, how did that work? How were these things bound, actually? Because you see that I have a product name here. There's apparently just one product name. But then I do a count, and my count is going to look at the sales variable, and it's going to find the quantity. Well, it turns out that each of these variables is bound to a sequence, and that sequence contains every value that that variable had in that partition. If you're part of the grouping key, then by definition you only have one value. So there's only one product name because it's part of the grouping key. The sales is going to contain every record that contributed to sales. And one way that you can see that is by looking at this query here. What I'm going to do is I'm going to just put the value of sales within the product element. And you can see here that sales is bound to a sequence of records, which is what it was bound to up here in the for expression before the grouping. The grouping actually creates a new tuple for each value of product name. Within that tuple, it gives you every record to which sales was bound. Okay, so that's how grouping works in XQuery. I'm going to do a quick time check, and I think I'd better not go into my other grouping queries. But you can certainly do joins across multiple tables and things like that. With your grouping, you can do fairly complex things. Nice things about grouping is that because it's high level, optimizers can look at it and take advantage of indexes. I've done grouping on fairly large data sets with reasonably good performance for fairly complex grouping. Second thing that I want to talk about is windowing. And windowing actually is a different kind of grouping. Windowing is grouping based on identifying the start and end of useful subsequences within a sequence. Okay, so let's say that you have a bunch of events. You might think that one set of events is the time from which somebody walks into a building to the time that they walk out. Okay, that's a window. Now, during that time, somebody else might walk in and then walk out. Those windows might overlap. Okay? You have other things such as stock windows where the price is going up and down during some period of time, things like that. You have windows in document structures because document structures are organized sequentially. I had something that I did with windowing recently where somebody had done an OCR of a dictionary that I was interested in. They had it as a Microsoft Word document. I converted it to a LibreOffice document. I got the XML out of it, and I used a windowing query with about 72 lines, I guess, that converted it to a TEI structured document based on information that was there. But it was all sequential. Every single paragraph was just one item in the stream, and I was able to extract enough information from things like the character set and the formatting to be able to do that. So what you do with windowing is basically two things. You say, here's how you tell when you found the start of a window. Then you say, here's how you find the end of a window. And then the window variable is going to be set to all of the items within that window. You say whether those windows can overlap or not. And then there's a detail, well, what do you do if at the end if you can find the start but you can't find the end because nothing satisfies the condition? There's a detail about that. It's most useful, again, as I said, for either document data where order is significant or for event streams. Like other grouping, it's often used together with sum, count, average. Like other grouping, you often use it to create XML hierarchies that represent the windows that you're interested in. Okay, I just said most of this here, so I'm going to go to my queries here. I'm going to do two windowing queries here. The first is based on, let me just get this to where I can actually read it. Yeah, the first is based on this data here. I must not have put that into my, okay. Here what I'm looking at is a bunch of individual items that I thought I had here, and I apologize, I really should have tested this out here, but the individual items are H1s and Ps and things like that, and they're just sorted individual linearly like you get in HTML. There aren't any divs in here, and I want to create a hierarchy out of this. And you see that what I do is I'm creating new sections that have the H1s going into titles here, and then the paragraphs within the sections. This is sort of a toy version of what I was talking about with the dictionary. And the other query that I wanted to do is based on a set of temperatures. And what I'm going to do here, let me see if I can. Okay, this is one of those things you don't want to have happen during a demo. But I have a bunch of temperature readings coming in. And what I want to do is do a moving average of those. And I'm going to say every window of 3 items I'm going to average. And I guess there's 2 things that I want to say here. The first is that I have a sliding window that I'm going to take my sets of entries and start with the first 3, then the next 3, the next 3. I don't slip past the first 3 that I used for that average, right? I'm taking these 3, then these 3, then these 3, and taking averages of them. So that's basically how windowing works. Second thing that I want to talk about is higher order functions. Third thing I want to talk about is higher order functions. And this is something where the functional programmers are saying, well, finally, we've got a functional programming language that has functions, and I can pass functions as parameters and get them returned from functions, and I can use functions that operate on functions for composition. If you're deeply into functional programming, that's just really, really important. A lot of XQuery programmers aren't deeply into functional programming and use it happily without using those things. Like windowing and grouping, this is something where one part of the community uses it a lot and one part of the community doesn't use it so much. I stole several of the examples here from the Basics wiki, so I thought I should acknowledge that. A function is just an item, so as in XPath and XQuery, currently you can have attributes or values or elements occur in a sequence. They can be passed as function parameters. They can be returned from functions. Now a function can appear in a sequence. A function can be bound to variables. A function can be returned from a function or be passed to a function as a parameter. If you have a function that takes another function as a parameter, it's called a higher order function. I guess the first one most people are exposed to in programming is you write something that sorts items, and it takes a function parameter to say how to compare 2 items. Most of your functions are not higher order functions. There's a relatively small number of higher order functions. Typically, they're used in a library. And we have a standard set that is pretty similar to those you find in many other higher order, many other functional languages. Here are some ways you can create a function item. This declares a new inline function. This particular function doesn't have a name. It's anonymous. What this function does is it adds 2 items. You see that it's bound to a variable. I can call the function from that variable binding, pass it some parameters, and it returns a result, which is the sum of those 2 numbers. Another way you can get a function item is to specify the name of an existing function. So here's the power function. In XQuery, you identify functions partly by the arity. So this is apparently a power function that takes 2 parameters. That #2 means of arity 2. And you see that I'm going to return that function with these 2 parameters. So it's going to raise 5 to the 2 power. A third thing you can do is called partial function application. Here you see that I'm identifying an existing function. I'm using a question mark for the parameters that I want to actually pass in. And I'm passing it constant values for the other parameters. What that means is when this is called, the second and third parameters are going to be 1 and 3 respectively. And the first is going to be whatever I supply as a parameter. So here, when I call f, the substring function is going to be called using the first parameter, foo1, 2, 3, the second parameter 1, the third parameter 3. Okay? We also have a set of higher order functions that are defined on sequences. We have the for each function. It takes an initial sequence, and for each item in that sequence, it calls the function that's specified as the second parameter. Now, if you want to be tricky, you can do things like this. You can pass it a set of function items as the first parameter, and then you can specify the function in your second parameter so that it's called for each of those function items. So what this is going to do is it's going to pass the foobar as a parameter to each of these functions. Okay. We also have filters. In a filter, the second parameter is a function that returns a Boolean result, true or false. And what it does is it takes the input sequence and it returns those items for which it evaluates to true. We also have something called for each pair that takes pairs of items. In this case, I should have tried this on this screen. In this case, it's going to concatenate. And each time it's going to take a pair of items from these sequences. So it's going to take the A and the X, and it's going to concatenate them. It's going to take the B and the Y and concatenate them, and the C and the Z and concatenate them. Another standard function that a lot of functional programmers are used to is called fold. What fold does is it takes items from the input sequence and it calls the function on them repeatedly in a given order. So here you see that I have the sequence 1 to 5. I give it an initial seed function of 0, and then the function is to add these up. What's going to happen is initially it's going to be called with the seed and the first of the items. Then it's going to take that result and use that as the first parameter. And it's going to call that with the second of the item. Then it's going to make that the first parameter and call it with the third item, and so forth. It expands out in that direction. There's also a fold right that goes in the other direction. Okay, last XQuery 3.0 that I want to talk about is try-catch. Try-catch is done for error handling. Imagine that you have, say, an XQuery that's running with function annotations for REST services, such as Atom Rudders. You don't want it to raise errors that return things that people aren't expecting. You want to catch those and handle them in an orderly way. So here's an example. You do a try. If you get an error, you catch it. There's some variables that you can use in your response to say, well, here's the error that it got, and the description that came from it. Okay, I've got to work very quickly through maps and arrays. Maps and arrays are just like you have in JSON, and we're adding them for two reasons: as a lightweight structure to be able to process things in your XML, and also to be able to handle JSON and other kinds of data, such as JavaScript objects, such as libraries that do natural language processing and return things using JSON structures, such as Atom feeds, and also for parameter passing. Let's say that you want to serialize and specify the XML method and your encoding and indent and such. Implementations are already doing this. We need a standard. There's several ways of doing this. We have a first internal working draft that we're going to be arguing out over the next week. I don't know when we're going to actually get it published. But we do have a desire to move quickly on this. With maps, we have a map constructor. Your keys can be any atomic value. Your values can be any value. So you have a key method and the value of XML, encoding, indent. You retrieve values using a function call. A map is a function. If I call it with the value of a key, it returns the value associated with that key. And you can nest them. So in an Atom feed, I can ask for the first entry's author's name. And you can process maps in ways that are fairly similar to, you can use grouping and windowing and whatever. Here's an example where I'm creating a nested map using the XQuery grouping operator. Because I'm out of time, I'm really going to have to run through this fairly quickly. Arrays are maps. Maps are functions. The difference between an array and any other map is that your keys are always positive integers. We have a simple syntax that gives you your standard kinds of arrays. The key for this first item would be 1. The key for the second would be 2. The key for the third item would be 3. So the key always identifies the position in the array. And you see that I can retrieve it in the same way that I would for a map. Arrays can nest. So I can retrieve at multiple levels. We also have a syntax that allows you to put things like null sequences and sequences of arbitrary length in as the value. And I'd better get off of the stage so that Michael K. can speak, because I've now used up the half an hour that I begged off of him. Are there any questions while he's setting up?